for a copper wire, root mass 0.08 kilogram. So this is the mass of the copper wire, and the length is the length of the wire is 0.2 meter, right? Attached to things current carrying the wire as shown in figure. So now we have current flow in the wire. The root perpendicular to the uniform electric field. So this is the direction of electric field here, meaning the direction is to into the page, right? And the magnitude of the B here, the B is given by 0.60 Tesla, and this means the magnitude and direction of electric current I. So what is the value of the current and the direction? To keep copper wire stay fixed and stay horizontal, meaning if the wire or copper rod stay at horizontal like this, meaning because the copper wire have the outer copper wire mass is 0.08 kilogram, meaning the copper wire must have a wake force, right? Wake force of copper wire is a mg. To keep the copper rod maintained or fixed at the position like this, meaning you must have a extra force X on the rod, okay, to overcome the wake force mg to downward. So now if for the current carrying conductor in the magnetic field B, so we have the force. So direction of the force to meaning you must have an extra force direction to upward. Let's say this is the force produced by the magnetic field, current carrying conductor, right? The force here is equal to the current flow in the conductor times length of the conductor and magnitude of magnetic field B sine theta. The theta is angle between L and B. Because according to the question is the rod is perpendicular to the uniform magnetic field. So meaning this is a sine 90. The sine 90 is equal to 1. So meaning the equation here, you have the force. The force here is equal to ILB. So now to calculate the current flow, now this is the force produced because of current carrying conductor in the magnetic field B. So the force, let's say we have, I think that is F subscript P. So the current flow to produce the force here is force divided by L and divided by B. And the next, the force here, because the upward force is equal to downward force to maintain the rod, copper rod at the position like this. So meaning the force here is equal to mg, right? And this is length of the rod and the magnetic field strength B. So put in the value of the mass of the rod is 0.08 and the G is constant 9.81 and the P is given by the question is 0.6 Tesla and the length of conductor is 0.2. So right, the current I to produce current, to produce force here is equal to 6.54 ampere. And the direction, so if you find the direction, you must use the left hand. So because direction of the B to downward, right? This is direction, use second finger downward, and the force to the direction of the second finger to into the page, and this is direction of the force, this produce force here, direction to upward to overcome the weak force. And if you look the left hand, okay, the direction of second finger is to the right, so this is the direction of the current flow I, right? Thank you.